Okay, our next speaker is going to be Jerry Weiland, who is a research plant pathologist with the USDA-ARS. As you can see, he's joining us virtually, and he's going to be talking about pathogen presence, distribution, and management options for soil-borne pathogens. So Jerry, go ahead and take it away.
Hey, good morning. Can you hear me okay? Can you hear me?
We can hear you just fine. Awesome. Thanks, Jerry.
Great, great. Good morning, everybody. As mentioned, my name is Jerry Weiland. I'm a plant pathologist down in Corvallis, Oregon with USDA-ARS. Today, I will be presenting research from the last 12 years or so that we've done in my lab on Phytophthora root rot and verticillium wilt of red raspberry, which I hope helps you better understand why soil-borne disease control has been so difficult up in Washington. The research I'm presenting today was part of a team effort involving the people listed here and was conducted in direct response to questions from you, the Washington red raspberry industry, all the growers who were interested in understanding and improving control for soil-borne diseases. I will be starting out today's presentation with a very brief overview of Phytophthora root rot and verticillium wilt, so we're all on the same page. And then I'll talk about our research, including a survey to determine which pathogen was causing the most severe disease in Washington on red raspberry, and an investigation into the biology of Phytophthora root rot. And then I'll start wrapping up with our research to see how well fungicides and fumigants have worked for managing these soil-borne diseases, and then end with some recommendations for you. So Phytophthora root rot is one of the soil-borne diseases I'm talking about today. In Washington and in British Columbia, it's mainly caused by Phytophthora rubi. 99% of the plants that we look at that die from this disease, Phytophthora rubi is the culprit. As Mark mentioned, these are water molds and they produce swimming zoospores. These are the little spores that swim through the water, and these are what's responsible for infecting and killing your plants. Phytophthora root rot tends to be worse in wet, heavy soils, and it is much more severe on red raspberry than on black raspberry. And my talk today is mainly focused on red raspberry, but I just wanted to mention that. The terrible thing about this pathogen is it survives for years in soil. So once you've got it, it's really hard to get rid of. And the picture here is just showing a heavy, wet clay soil that's all cloddy, and you often see horsetail in fields where Phytophthora root rot is a problem. Contrast that to verticillium wilt. This is primarily caused by Verticillium dali, which is a fungus, not a water mold. It does not produce swimming zoospores, and it tends to be a bigger problem on drier soils. Particularly, it becomes severe after potato rotation. Potato is very susceptible to this pathogen, and you can really build up soil populations of verticillium that can be damaging to red raspberry in these situations. This disease tends to be a lot more severe on black raspberry. There are decades of research showing red raspberries are quite a bit more tolerant or resistant to verticillium wilt than black raspberries. But again, it can become a problem if you've got high soil populations. And this is another pathogen that also survives for years in the soil. So once you have it, you've got it for a long time. Some common assumptions that I wanted to talk about. One common one that we commonly hear about Phytophthora root rot is that it's a cool weather disease, while verticillium wilt is a warm weather disease. For root rot, symptoms usually begin in May, June, and the older scientific literature often claims that infection by Phytophthora rubi occurs primarily in the fall and winter when soils are wet and cold. But this is an assumption. I want to emphasize that, and I hope I change your mind by the end of this presentation. This is an assumption that's not based on any research data. And contrast that to verticillium wilt, where we do have more data. It tends to be a warm weather disease where symptoms begin in July and August, and infection tends to occur when the soils are warmer and drier. So with that out of the way, my research in red raspberry began about 12 years ago in 2012 when growers up in the Linden and Whatcom County areas were very concerned about the sudden collapsing and dying of red raspberry plants in late summer. They were wilting and dying all over the place. And there were contradictory reports. Sometimes there were populations of verticillium in the soil, and there was at least one grower where verticillium was isolated from his plants. So there was a concern that there was a previously undocumented verticillium wilt problem. The disease tended to occur on dry sites with no history of Phytophthora root rot, and the lifespan of these plantings was decreasing over time. So to figure out what was causing the disease, in late summer, August and September of 2013 and 14, I went up to Whatcom County and sampled plants and soil from 24 fields. And from each of those fields, we collected plants from disease sites and healthy sites. So healthy sites within the field had lush, green, beautiful red raspberry plants that weren't dying at all, whereas the disease sites tended to have disease pockets where the plants were collapsing and dying. The primocanes, like this one here, hopefully you can see my pointer, started wilting and dying, and then they would die and collapse. In places where we didn't see these symptoms, we also took samples from areas where the plants were turning yellow and dying out and were stunted. We looked for three main pathogens. We looked for Patalanchus penetrans, the root lesion nematode, and for verticillium and for Phytophthora. So let's find out which of those three pathogens were responsible for killing the raspberries in late summer. Starting with root lesion nematodes, we see that 92% of the time we found Patalanchus in disease sites where the plants were wilting and dying. That may seem like good evidence that nematodes were causing the problem, but if we look at the sites where the plants were healthy, we find nematodes almost as often. About 80% of the time that nematodes were present, they weren't causing any noticeable disease at all, meaning that the canes weren't wilting and dying. This tells me that nematodes were probably not the problem causing those plants to die in late summer. And to use an analogy based on recent events, imagine that you were at a family Thanksgiving buffet last week where half the people at the event got food poisoning and the other half didn't. Although 92% of the people at your event got food poisoning, although 92% of them had eaten potato salad, you have almost the exact same percentage of people, or 80% over here, who also ate the potato salad and didn't get sick. So more than likely, it wasn't the potato salad that caused the food poisoning here, and it also wasn't the nematodes that were causing those plants to wilt and die here. So moving on, we have almost the exact same situation for verticillium, although it was present in 86% of the time at disease sites where the raspberries were dying. It was also present 85% in the sites where all the plants were completely healthy. Therefore, verticillium is also not was killing most of the red raspberries that summer. Instead, when we look at Phytophthora results, we see that this pathogen was more than twice as likely to be present in sites where the plants were dying than in sites where the plants were healthy, or 86% versus 40%. So ding, 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 we likely have the main culprit here that was responsible for killing red raspberries that summer. And to go back to my Thanksgiving analogy and to a dish that I think is absolutely disgusting, this would be similar to saying that those who ate the green bean casserole at dinner were more than twice as likely to get sick as the people who didn't eat it. So another way of looking at this, I want to show you what happens when we look more closely at the results from the soil samples versus the plant samples. Looking at just the soil results, we found Patalanchus, or the root lesion nematode, in the soil at 90% of the disease sites, verticillium in the soil at 75% of the disease sites, and Phytophthora in the soil at 65% of the disease sites. Some people might interpret this as meaning that all three of these were causing the plants to die, but if we take a look at which pathogens were actually isolated out of the plants that were dying, so here we have a primocane that is wilted and dying, and if we go back to the base of the cane, we see this purple lesion extending up. We isolate from that to find out what is killing those plants. None of the time did we find root lesion nematodes. About 6% of the time, We did isolate Verticillium dahlia, so Verticillium dahlia is killing plants, but not very many. And about 9 times more, or 54%, it was Phytophthora rubi that we found killing these plants in late summer. What about that other 40%? More than likely, it is also Phytophthora rubi. It is extremely hard to culture out of canes, and the success rate is roughly 50%. So my guess, and knowing the symptoms, you probably have Phytophthora killing these plants 90% of the time or more. What I want you to get from this is that soil tests indicate risks. If verticillium is going to be in almost all the agricultural soils there, but that does not tell you what is actually killing your plants. To know what's killing your plants, you have to isolate from the plants that are dying. And in this case, Phytophthora was usually killing the plants, not verticillium. So this made me question some of the assumptions about Phytophthora biology, and hopefully it does you too. On the one hand, all the old literature says that it is a cool weather pathogen that primarily infects from fall through winter when soils are wet and cold. But then why are we seeing so much death due to Phytophthora in late summer? To answer that, we ran a study to see how temperature affected the ability of Phytophthora rubi to grow, sporulate, and cause disease at 4 different temperatures ranging from 40 to 70 degrees. And the reason we chose these temperatures is because it reflects the range of temperatures throughout the year in northern Washington fields. So in winter, coming up in January through March, the soil temperatures are 40 to 50 degrees. They increase to 60 and 70 degrees in the spring and summer, and then decrease back down to 50 and 40 degrees in fall. And then thinking about the moisture aspect of it, you're getting a lot of rain in November, December, up to 4 to 5 inches per month, and pretty high rain also in January through March, but then that rain goes down. So according to the old literature, fall over here in green and winter are the times for most infection, but is that actually true? So we looked at growth at 40, 50, 60, 70, and sporulation with those little swimming spores. What we find is Phytophthora rubi grows barely at all at 40 degrees, doesn't like that temperature, grows a little more at 50, grows even more at 60, and then grows the fastest at 70 degrees. And for sporulation, it does not sporulate at all at 40 or 50 degrees, and that's bad for infection. It will not infect at these lower temperatures. But at 60 degrees, it starts out sporulating slow, but then it increases sporulation by the following few days from 4 to 8 days. And there's even more sporulation at 70. So that tells me we're probably going to get more disease at 60 and 70. Sure enough, if we look at the results, there was little to no disease at 40 to 50 degrees Fahrenheit. And most of the disease was occurring at 60 to 70 with this amount, with these different symptoms. And if we take a look at the biomass in green, these are grams. In green, we have the healthy plants and how well they grow. Your healthy plants don't like growing at 40 degrees. They barely grow at 50, and they start growing faster at 60 and 70 degrees. And if you look at disease, you really can't, and disease is here in the orange, you really can't see much disease at 40 degrees. You start to see a tiny bit at 60, but it's not different than the biomass isn't significantly less than the healthy plants. Where you start seeing the difference and the plants are significantly shorter and more unhealthy looking is at 60 and 70. Just to show you what that means, when we started out with tissue culture meeker plants, this is at the beginning of the experiment, what they looked like in the growth chambers. All the plants looked terrible at 40 degrees Fahrenheit. It didn't matter whether they had Phytophthora rubi or not. The plants don't like growing at 40. But if you look at 70 degrees, you can see these plants are growing. These are healthy plants in the background. There's a couple disease plants here. You can really see disease take off, like this plant here and this plant here. Disease is really bad at 70 degrees. So take home point here. Phytophthora is a warm weather pathogen that is active in spring and summer, not fall and winter. But I hear a lot of you thinking, well, what about these dry sites? Phytophthora is supposed to like moisture. Well, most of you are irrigating. I know you tend to irrigate less during late summer, but if you have enough water for growing raspberries, you have more than enough water for Phytophthora root rot to happen. So essentially, you are taking a dry soil or what would be naturally dry, you're adding water to it, and that's enough for Phytophthora to grow. Talk really quickly here about Phytophthora fungicides. We isolated 152 isolates of Phytophthora rubi from 25 fields in Whatcom and Skagit counties, and we found absolutely no evidence for resistance to the three most commonly used fungicides, methanoxam, which is in these products, phosphorus acid in products like these, and oxathiopyperlin. So fungicides should be working for you. However, I want to emphasize a few points. Fungicides suppress growth, sporulation, and infection by Phytophthora. They don't kill Phytophthora. So as soon as those fungicides wear off, and they wear off in about a month, that Phytophthora can start growing again. So that means most of you are applying fungicides in the fall, and I've just highlighted that here in orange. Those fungicides are wearing off after a month. Phytophthora not doing anything in the fall. It's just sitting there. It's cold, it's wet, it's yucky. Phytophthora doesn't like these lower temperatures. So those fungicides start wearing off. And by the time you get, let's say you apply in October and November, 1, 2, 3, 4, 5 months. By the time you get to April, when Phytophthora starts growing again, those fungicides are long gone and not protecting your crop, and you're likely getting a lot of infection occurring here. So my advice is to start trying applications in spring and summer. One thing I heard is that a lot of growers don't like phosphorus acid for managing this disease. They find it doesn't work. And I looked through the literature or a lot of the pesticide labels, and most of the phosphorus acid labeled for raspberry is labeled for foliar applications. And I don't think that's very effective. We have a similar study on Phytophthora cinnamomi, which is highly related to Phytophthora rubi on rhododendron. And in rhododendron, we compared foliar versus soil drench applications. And if we don't apply any fungicide at all to this rhododendron, about 90% of those plants are killed. If we apply methanoxam and phosphorus acid at the maximum label rate to the foliage, those we have a similar amount of plants killed. 80 to 90% of them were killed. And this is because not enough active ingredient goes from the foliage down to the roots to protect them from Phytophthora root rot. Compare that to soil drenches with methanoxam and phosphorus acid, where you drop the amount of death by over half to 2/3. So I think the same thing is probably going to occur with raspberries. If you're applying to phosphorus acid to the foliage, it's not going to do a darn thing for you because there's not enough active ingredient going down to the roots where the pathogen is. So if you're interested in phosphorus acid as a control, there are a few that are labeled for soil applications in red raspberry, and that would be my recommendation there. Last, I want to talk about fumigants. We had a 2017 bed fume trial where we compared the industry standard of Telone C35. There's the stats there, injected at a 16-inch depth. And we compared your typical not tarping, and we compared that to tarping. And was there a difference in control? Fumigants are supposed to kill all soil-borne pathogens, or most of them, and that sort of essentially disinfests your soil so you can start again. And we weren't able to find a field with heavy verticillium or Phytophthora pressure. So in place of verticillium, we assessed Fusarium populations, which is what Mark Bolda talked about. And in place of Phytophthora, we assessed Pythium. And Pythium is related to Phytophthora. Both of these are a lot easier to kill than either verticillium or Phytophthora. So if the fumigants aren't working for Fusarium and Pythium, they're not working for verticillium and Phytophthora. And we did also evaluate root lesion nematodes or Pratylenchus. There we got great control. We reduced the populations to 0, but I'm going to just talk about Fusarium and Pythium. So if you did nothing, Starting before fumigation in 2017, the fusarium soil populations were about 7,000 little units or little propagules of fusarium per gram of soil. And this is because you've incorporated all that organic matter from the roots and ground it all up and put it into the soil. Fusarium loves organic matter, so we had high populations. If you did nothing, those populations slowly decrease over time after fumigation at planting. There was a slight bump up in the fall of 2018, but by the time that planting is roughly a year old, two summers old, the populations are still there. If you follow the industry standard, you have basically the exact same trend. That's here in blue. And in fact, the populations were a little higher. So your fumigation without tarping doesn't do anything at all to fusarium. It's not going to do anything at all for verticillium. And if you tarp, it's almost the exact same results again. Those populations slowly go over time. Whatever the formulation is that you're using, the Telone C35, it is not very effective for soil-borne fungi. And the other thing I want to point out is even after fumigation, you still have a lot of fusarium in your soil. And you would, if you had verticillium, you'd have a lot in the soil. There's plenty of fungal inoculum left in the soil after you fumigate to cause disease again. So fumigation, what you're doing right now, has not been effective. And forest nurseries have done some fumigation trials, and for forest nurseries, they want to see populations at or near zero after fumigation. They want to see that population knocked back to nothing. If we take a look at Pythium, we see that if you don't fumigate at all, the amount of Pythium in the soil tends to stay pretty stable over time. It goes up a little once the plants are in at planting, and that's because Pythium needs the roots to start infecting and killing. It does some minor root damage. And here's your industry standard non-tarp C35. What we see is, sure enough, there are your standard fumigation is knocking back the populations a little bit here. It's still not knocking it back to zero, but this is better than nothing. And I would expect your industry standard fumigation would be knocking back Phytophthora rubi as well. But once you tarp, you really knock those populations back even more. There was a brief uptick in fall 2018, and we just happened to hit a pocket of inoculum here that bumped it up. But tarping is knocking it back to more significantly than not doing anything at all and more than your non-tarp standard. But there is still Pythium inoculum and thus Phytophthora inoculum in your soil even after tarping. And that's telling me there's enough inoculum here to start disease again. That's telling me you're not getting good fumigant control. Again, in forest nurseries, they'd want to see those populations down near zero. So in my point of view as a plant pathologist, this is unacceptable fumigation control. So why is your fumigation control so poor? I think one, most growers aren't tarping. I do wonder about injection depth. Raspberry, you tend to be injecting down about 16 inches. In forest nurseries, they're only injecting down about 9 inches. And also your formulation. It's optimized for nematode control. It is obviously not optimized for Phytophthora or verticillium control. And this is where some research could be done to find out which fumigants would, or which formulations and combination of fumigants would work better for you. Take-home points. In Washington, probably the number one main problem for you is Phytophthora, not verticillium. Although verticillium can be a problem after rotating with potato. I know you like rotating, some of you like rotating with potato, but stop it. I think that's a big risk. If those populations go up, you're going to get vert wilt. Detection of verticillium wilt in the soil is not enough to determine the cause of disease. 95% of the agricultural soils will have verticillium in it, but that's not necessarily what's causing the disease. You need to isolate from your plants that are dying to figure out what's killing them. The other take-home points is Phytophthora is a warm weather pathogen, not a cool weather pathogen, and Phytophthora is also a problem on your drier sites because of irrigation. And from my point of view, most of your soil-borne disease management methods are not very effective. I think that's why you've struggled for a long time with keeping your plantings surviving as long or lasting as long as they used to. You are not adequately controlling soil-borne pathogens, fungi, and Phytophthora. So the fungicides should help, but they need optimization. I think you need research comparing spring and summer applications to fall. And you should also compare, if you're interested in phosphorus acid, you should compare soil drenches to foliar applications to see if you can improve control. And lastly, for the fumigation, your untarped T-Lone C35, in my opinion, is marginal to completely ineffective against soil-borne fungi and water molds. You need to start tarping to improve effectiveness, start some research to compare different formulations to see if you can get the populations to drop down near zero, and comparing injection depths. And with that, I think I'm right at 28 minutes. So I don't know if there's time for any questions.
Thank you, Jerry. Yes, if you have time, we would love to have a couple questions. Um, Again, you can text your questions, or even if you have comments and want to provide feedback or suggestions, you can also text it on here. Are there any questions in the audience first?
And I'll also be at the panel after the break.
Perfect. Jerry, you might have answered everybody's question. It was just that thorough.
It was a lot of information. So
What's the average cost per acre to tarp fumigate? What per acre on berries? What would you find?
I honestly don't know. It's been a while since I've done this research. I would say 5 years. Back then, I was thinking, what was it, 500 to $1,000 per acre? Does anybody out in the audience know, or Chris?
I think Chris is looking it up right now, grabbing a microphone.
I know it was more expensive, but from my point of view, like if you have a bad Phytophthora root rot problem and the age of your planting is decreasing significantly, you have to sort of weigh that cost.
Sorry, what was the question, Jerry? I missed that.
What is the cost of tarping?
500 bucks. Riley Juan. Cost of tarping. 1,000. Yeah,
1,000.
And also 500 for removal.
So an
3 grand.
additional.
Great. We actually have a question online, Jerry. They said, what should a grower do since it appears fumigation doesn't work?
Well, it's basically what's been done for the last few decades. My I know we're concerned that fumigation is going away. I think in the short term, I would be looking for formulations that maybe have more chloropicrin and or other fumigant chemistries that would be more effective against soil-borne pathogens. Forest nurseries are using, oh gosh, I'm not going to remember. They are using T-Lone and chloropicrin as well. They just have a higher rate of chloropicrin and a lower dose of the 1,3-D. So that might be one option. And tarping. There are, I think, also focusing on resistant crops and anything you can do to reduce the amount of water that is applied to your plants will help.
So, yeah, Jerry, Mark, UC Cooperative Extension, California. So what you're saying about the formulation of the fumigant, that rings very true. In California, they're going more and more to pure formulations of chloropicrin, 350 pounds per acre. But I tell you, it puts the ag commissioner in fits because that rate is so high.
Yeah.
But that's what we need to be efficacious. Yeah, thanks.
All right. So with that,